from one of the most visited islands in the world, there is something that most people have no idea about. A massive magma chamber hidden at the bottom of the sea, growing silently for nearly 400 years. And the most impressive part is that scientists only discovered this recently. We are talking about the Colombo volcano, a submarine volcano located near the Greek island of Santorini. And what is happening beneath it has been worrying researchers all over the world. When we think about volcanoes, the first image that comes to mind is a mountain with lava flowing down, right? But beneath the oceans, there are far more volcanoes than on the surface. And the problem is that most of them we simply cannot see. Colombo is one of those. It sits about 1,600 feet, 500 meters below the sea surface along the Hellenic volcanic arc, the same region where one of the largest eruptions in human history took place, the eruption of Thera, around 1,600 years before the Common Era, which practically wiped out the Minoan civilization. And the last time Colombo erupted was in 1650. Back then, pyroclastic flows crossed the sea surface and reached the shores of Santorini. Toxic gases spread across the island, and 70 people lost their lives. For that era, with a much smaller population, it was a devastating event. And here's what caught my attention when I started researching this subject. Since 1650, nearly 400 years have passed, and during all that time, Colombo stayed silent. But silence when it comes to volcanoes does not mean inactivity. Quite the opposite. It can mean that something is building up below, out of our sight. And that is exactly what scientists confirmed with the discovery that surprised even the most experienced in the field. The most active volcano in the Mediterranean was hiding a secret beneath the seafloor. And when researchers finally managed to see what was down there, the data were alarming. Because we're not talking about just any volcano. Colombo is part of a volcanic field with at least 25 submarine cones, all aligned to the northeast of Santorini. It is a geologically complex region where the African plate dives beneath the Aegean plate, creating perfect conditions for large-scale magma accumulation. And the question scientists had been trying to answer for years was simple: how much magma is down there? The answer they found exceeded all expectations. A study published in October of 2022 in the journal Geochemistry, Geophysics, Geosystems brought a revelation that changed the risk assessment for this entire region. Using a cutting-edge technology called full waveform inversion, which works in a similar way to a medical ultrasound but applied to volcanoes, the team led by Kyotan Trepiach, a geophysicist at Imperial College London, managed to see what no traditional method had ever detected before. The technique works like this. The researchers fire sound waves from a research vessel, and those waves travel through the ocean floor. When they pass through solid rock, they travel fast. But when they encounter magma, molten material, the speed drops dramatically. Using that difference in speed, scientists can build a detailed image of what lies beneath the volcano. It's like an X-ray of the interior of the Earth. And what the image revealed was a magma chamber that nobody knew existed. It extends from about 1 1/4 miles to 2.5 miles deep, 2 to 4 kilometers below sea level, with a width of roughly 2,000 feet, approximately 600 meters. The total volume of accumulated magma is 1.4 kilometers, which is about a third of a cubic mile. That sounds abstract, does it not? So think of it this way. That would be enough to fill more than 500,000 Olympic-sized swimming pools with molten rock at temperatures exceeding 1,800 degrees Fahrenheit, over 1,000 degrees Celsius. And what really stands out is the rate of growth. According to the study, this chamber has been growing at an average of 141 million cubic feet, 4 million cubic meters per year since the last eruption in 1650. 141 million cubic feet every single year without stopping. Trepiach himself explained that if this growth rate continues, at some point within the next 150 years, Colombo could reach half a cubic mile, 2 cubic kilometers of magma. You know what that represents? It is exactly the estimated volume that was expelled during the 1650 eruption. In other words, the volcano is recharging itself for something comparable to what happened nearly 400 years ago. And the authors made a point of highlighting that the characteristics of this system indicate a highly explosive eruption, comparable in style, although of lesser magnitude, to the Hunga Tonga eruption of 2022. If you remember, that eruption in the Pacific generated tsunami waves up to about 66 feet, 20 meters high, and an eruptive column that reached the stratosphere. Now, imagine something with that kind of potential just about 4 miles, 7 kilometers from an island with 20,000 residents and 3.2 million tourists per year. But the story does not stop there, because in January of 2025, something happened that brought all of this into sharp focus. On January 27th, an unexpectedly intense earthquake swarm began to be recorded about 6 miles, 10 kilometers northeast of Santorini, right in the region of the Colombo volcano. And these were not just a few tremors. Over the course of approximately 30 days, more than 30,000 earthquakes were recorded between the islands of Santorini and Amorgos. The University of Athens reported over 15,000 quakes in just 15 days, something never documented in that region with such intensity. The largest tremor reached magnitude 5.2 on the moment magnitude scale. The Greek government declared a state of emergency on Santorini between February 6th and March 3rd of 2025. Schools were shut down. Residents were told to drain their swimming pools because the movement of water could destabilize the buildings. Around 11,000 people left the island voluntarily, and then came the scientific response. In November of 2025, a study published in the journal Nature provided the explanation, and what the researchers discovered was even more surprising than the crisis itself. Santorini and Colombo, two volcanoes that were believed to be separate systems, are in fact connected by a shared deep magmatic system. The data showed that the gradual inflation of the Santorini caldera, which began in mid-2024, preceded the intrusion of a magma-filled dike sourced from a mid-crustal reservoir beneath Colombo. Think about the scale of that. Two extremely dangerous volcanoes, about 4 miles, 7 kilometers apart, fed by the same deep reservoir. The research team analyzed more than 25,000 earthquakes using artificial intelligence and concluded that sheets of magma sliced through the crust at depths greater than 6 miles, 10 kilometers, covering an area of about 12 miles, 20 kilometers. The volume of magma involved in this intrusion would be enough to fill, hold on, let me check the exact number, 200,000 Olympic-sized swimming pools. The magma did not reach the surface this time, but scientists warned that this interaction between the two volcanoes significantly increases the risk of future activity in the region. And there is a detail that almost went unnoticed. During the crisis, the seafloor above Colombo sank by as much as about 13 inches, 32 centimeters, while the surface of Santorini rose by more than 4 inches, 10 centimeters. These movements indicate that magma was redistributing between the two systems in real time. It is as if the two volcanoes were breathing together, exchanging pressure between them. This completely changes how risks in this region need to be assessed going forward. And if Colombo is already concerning, there's another volcano in the Mediterranean that deserves attention. Marcelli sits in the Tyrrhenian Sea about 109 miles, 175 kilometers south of Naples, Italy. It is probably the most underestimated volcano on the entire European continent. A volcano about 43 miles, 70 kilometers long, and about 19 miles, 30 kilometers wide, larger than Mount Etna. It rises nearly 10,000 feet, 3,000 meters from the seafloor, with its peak just about 1,500 feet, 450 meters below the surface, and almost nobody has heard of it.
The Italian National Institute of Geophysics and Volcanology, known as INGV, has warned that Marseille has fragile walls made of unstable rocks fed by a shallow magma chamber. Simulations by the University of Bologna showed that in a scenario of partial flank collapse, tsunami waves would reach the Aeolian Islands in approximately 10 minutes and the coasts of Calabria and Sicily in 20 minutes. In the most extreme scenario, tsunamis up to about 66 feet, 20 meters could hit the coast. And the Mediterranean, unlike the Pacific, does not have a robust tsunami warning system. The distances are short and the reaction time is minimal. But here is the most important part of everything discussed in this video. Scientists are not standing still. In December of 2025, the research vessel Meteor departed on the multi-mar expedition to Santorini with the goal of testing innovative submarine monitoring systems. The Santorini Observatory has been monitoring Colombo since December of 2022, and new seismographs were installed inside the volcano's crater during the 2025 crisis. Our understanding has advanced more in the last 3 years than in the previous decades, and every new piece of data makes risk assessment more precise and preparedness more effective. And I will keep following every publication and every new piece of data that comes out about this region, because what is happening in the Mediterranean is one of the most significant geological events of our generation. If this video helped you understand the scale of what is hidden beneath the sea, subscribe to the channel and turn on notifications, because every week there is new content based on real data and verified scientific sources.
And if you know someone who is interested in geology or planning to travel to Greece, share this video. Information and knowledge are always the best form of preparedness. And if you want to keep learning about what is going on beneath our feet and beneath the oceans, stay tuned, because in the upcoming videos, I will go even deeper into each of these volcanoes.